The Defining the Problem unit introduces rocketry and designing controlled experiments. In this unit, students will get to make 3 types of rockets: paper rockets, straw rockets, and water rockets. All of the materials for the 3 types of rockets will ship together, but this video will focus on the paper rockets and straw rockets. The paper rocket activity uses copy paper, index cards, tape, and scissors. Students have to come up with a creative solution for using these basic materials to create an air-powered rocket. Their goal is to design a rocket that launches the farthest in the class. I usually put my students in groups of 2 for this activity, but if you have a smaller class or plenty of time, you can let each student make their own rocket. If you let your students test and modify their rockets, this activity may take a few days. If you're short on time though, you can spend most of the class period building and the last few minutes having a contest. Since the paper rockets do not tend to be as airtight as the straw rockets, you will have plenty of room to launch them in the hallway. Always make sure the launcher is securely attached to something and no one is in front of the launcher. The straw rockets are made out of straws, clay, index cards, and tape. Once again, students are trying to design a rocket that launches the farthest in the class, but this time they will go through the process with a controlled experiment. I use the presentations in the unit to reinforce how to identify independent, dependent, and constant variables before we begin the lab. The design brief directs students to start by testing different masses for the nose cones by creating 2 identical rockets and only changing the nose cone masses. The next step is to test 2 rockets that are identical except for the lengths of the straws. Students get to continue manipulating other variables such as the shape of the nose cone or the size, shape, and number of the fins. My students work in groups of 2 or 3 to create and test their rockets and fill out the design brief. I also have them individually do a lab write-up that matches a format their science teachers use. Students should document the angle of launch and the PSI as they are experimenting. These should remain constant unless they're using one as their independent variable. The straw rockets launch pretty far, so I would recommend testing them outside. When I have some extra time, I have a target contest. Students launch their chosen rockets at different angles and PSI and record this information along with where it lands. I place a bucket in a preset range and they have to predict the angle and PSI to get their rocket to land in the bucket on their first try.